California bearing ratio value test was developed by California State Highway Department of USA for evaluation of subgrade strength of highway and airfield pavements. The test is commonly known as CBR test. California bearing ratio value is defined as the ratio of load per unit area required to penetrate a soil mass by a standard plunger at a specified rate to that corresponding required for penetration of a standard material. The standard material is the one defined as having a CBR value of 100%. CBR value is usually determined at 2.5 mm or 5 mm penetration. The apparatus as per IS 2720 part 16 comprise of a mold with internal diameter 150 mm and a height of 175 mm with a detachable collar, a detachable base plate having perforations at the bottom, a spacer disc of 148 mm diameter and a height of 47.7 millimeters. Surcharge weights of mass 2.5 kg each and having a central hole of 53 mm diameter, a slotted weight, a penetration plunger of diameter 50 mm and height 100 mm, a loading machine of capacity 5000 kg and capable of travelling vertically at a rate of 1.25 millimeters per minute. Others like compaction rammers, proving ring, dial gauges, balance, filter papers, mixing tools, a tray to contain the specimen and a measuring cylinder. The test procedure consists of two parts: preparing test specimen and penetration test. The test specimen can be prepared either by static compaction or by dynamic compaction. In static compaction, a gradually increasing load is applied, whereas in dynamic compaction, the specimen is compacted by a suitable rammer. A dynamically compacted specimen can be prepared either by light compaction or by heavy compaction. In light compaction, the specimen is prepared by filling it in 3 layers using a 2.6 kg rammer with a free fall of 31 centimeters. A 56 number of blows are given to each layer. In heavy compaction, the specimen is compacted in 5 layers using a 4.89 kg rammer with a free fall of 45 centimeters, giving 75 blows to each layer. Now let us see as how a dynamically compacted specimen is prepared. First, to assemble the mold, place the spacer disc with threaded hole facing bottom side at the bottom of base plate. Place a filter paper at the top of it. Apply a lubricating oil to the inner side of the mold. This is to prevent the stickiness of soil to the mold. Also fix the collar. And tighten the clamps. Now take about 5 kg of the soil, passing 20 mm sieve. To the soil, mix a predetermined quantity of water such that the water content of the soil is either equal to the OMC or equal to the field moisture content, as the case may be. Mix water and soil thoroughly so as to prepare a mix of uniform consistency. Transfer the soil into the mold and fill such that after compaction the layer is about 1/3 or 1/5 of the total thickness, as the case may be. Now compact by giving suitable number of blows, which should be uniformly spread throughout the area. The hammer should be allowed to fall freely like this. After compacting the layer, scratch the top surface of the layer and add more soil for subsequent layer. Compact in the similar manner. After compacting the top layer, remove the collar and trim off the top surface. Also remove the base plate. Remove the filter paper and note down the weight of the mold filled with soil. Remove the spacer disc along with the filter Place another filter paper at the bottom. Place the mold such that the compacted surface is at the bottom. And place an annular weight of mass 2.5 kg. Place the assembly on pedestal of the loading machine. Set the proving ring and dial gauge in position. Place the assembly on pedestal of the loading machine. Now fix the plunger. Bring the plunger in contact with the soil surface and apply a seating load of 4 kilograms. This is to establish good contact between soil and plunger. Now add another 2.5 kg slotted weight at the top. Set the dial readings to 0. Allow the plunger to penetrate at a rate of 1.25 millimeters per minute. Note down the readings on proving ring corresponding to a penetration of 0.5, 1, 1.5, 2, 2.5, 4, 5, 7.5, 10 and 12.5 millimeters. Sometimes the curve may exhibit a concavity in the beginning, in which case a correction is to be applied as shown. From the curve, determine the load corresponding to 2.5 millimeter and 5 millimeter penetration, and compute CBR value as test load corresponding to the chosen penetration divided by standard load for same penetration multiplied by 100. The standard load values for a particular penetration are chosen from this table. Generally, CBR value for 2.5 millimeter penetration will be greater than that at 5 millimeter penetration, and in such a case the former is taken for design purpose. The results obtained by this test can be used to determine the thickness of flexible pavements using Indian Road Congress specifications.